The output remains at the present state. Clock equals 0, data equals 0, Q equals 0, and the output of Q bar equals 1. Data changes from 0 to 1, clock remains at 0, and the output does not change. Clock changes from 0 to 1 while data stays at 1. Therefore, the circuit is in the set state, making Q equals 1 and Q bar equals 0. Clock returns to 0 while data stays at 1. The output latch is in the quiescent condition, thus the output does not change from Q equals 1 and Q bar equals 0. Data changes from 1 to 0 while clock stays at 0. The output stays the same, Q equals 1, Q bar equals 0. Clock changes from 0 to 1 while data equals 0. This causes the flip-flop to go in the reset state, and thus Q equals 0 and Q bar equals 1. Clock stays at 1 while data changes from 0 to 1. Q equals 0 and Q bar equals 1. The flip-flop is locked out and unresponsive to further changes in the input. Clock changes from 1 to 0 and data stays at 1. The output does not change and the output latch is in the quiescent condition. Data changes from 1 to 0 and clock stays at 0. The output stays the same. Clock changes from 0 to 1 and data stays at 0. The flip-flop is in the reset state and Q equals 0 and Q bar equals 1. Clock changes from 1 to 0 and data stays at 0. The output latch is in the quiescent condition and there is no change to the output. Data changes from 0 to 1 and clock stays at 0. There is no change to the output. Clock changes from 0 to 1 while data stays at 1. The flip-flop is in the set state and thus Q equals 1 and Q bar equals 0. Data remains at 1 while clock changes from 1 to 0. This places the output latch in the quiescent condition without changing the output. Q equals 1 and Q bar equals 0.